This video will compare the formulas for the t-test for two related samples to the t-test formulas for the one sample t-test that we covered back in Chapter 9. Basically, the t-test for two related samples is very similar to the t-test for the single sample back in Chapter 9. So when we did a one sample t-test, the formulas are going to be very similar to the t-test for repeated measures. The main difference is instead of a raw score, we're using difference scores because we have a repeated measures design. So the difference score, or D, is going to be x2 minus x1. So we have a population of difference scores that we're going to obtain. So here's subject A, and so A, B, C, D, these are all different subjects or participants. They have a score from time 1 and a score from time 2. Whether this is before and after, or brightly lit room, dimly lit room, hot room, normal temperature room, whatever it is, and they have a score for each condition. We take the difference of those scores of x2 minus x1. So here, 14 minus 10 is 4, 13 minus 2 is negative 2, and so on. So we need to get a mean that's based on the sum of D. So our mean for our difference score is going to be the sum of the difference scores over the number of individuals in our sample. So if we were to add all of these up, 4 minus 2 plus 3 plus 1 is going to give us 6. We divide that by 4, and our mean difference would be 1.5. So our hypotheses will look similar as well. So the hypothesis, our alternative hypothesis, is going to be that the mean difference for the population is equal to 0, so that there is no mean difference. There is no difference between the conditions. Our alternative hypothesis would be saying that there is a difference, and of course this is a two-tailed or non-directional test. There is a difference between the two conditions. So here's just a comparison of the two formulas. This was our formula for the t-test for a single sample, and here's repeated measures. So here we had our sample mean versus our population mean, and our estimated standard error was our denominator. Now we're going to have our sample statistic, which is our mean difference, and our population parameter, which is our population mean difference, and we're going to have our estimated standard error down here for the mean difference. Our hypotheses look very similar. And here are the formulas for the t-test for the related samples t-test. So here is our t formula. Again, very similar, but now we're just talking about difference values. The variance of D is going to be the same formula that we've seen. Standard error for the mean difference, same formula that we've seen. We're just using a slightly different notation here to note which t-test we're discussing.